Okay, class, in this lesson, you are going to learn to find the lengths of segments using proportional relationships in triangles, resulting from both parallel lines and triangle angle bisectors. So let's go ahead and get started. So in this example, we're going to explore proportions from parallel lines, okay? So in this triangle, JLN, okay, we are given the fact that KM is parallel to JN. We know that they're parallel because of this notation, this arrow sign. Okay, so those are parallel. And the question here is if the length of LN, so this big right side of the triangle, is 9.6, what are the lengths of LM and MN? Okay, so we need to determine the lengths of both of those segments, and we need to determine if the sides are divided proportionally. Okay, so the first thing we want to do in step one is determine how triangle JLN and KLM are related. Okay, notice that we have this big triangle here, and then we also have this small triangle as well. Okay, so the first thing we will notice is that they both share angle L. Okay, so that tells us that angle L for the large triangle is the same as angle L for the small triangle. Okay, and then the second thing that we notice is that angle K, angle K here, or we can call it angle LKM, is equal to angle LJN. Okay, so this angle here and this angle here are the same. And they're the same because if you think about both of these lines that are parallel and they're cut by a transversal, okay, these are then considered corresponding angles. Okay, so the second thing that we know is that angle LKM is congruent or equal to angle LJN. Okay, so what we can conclude then is that triangle JLN is similar to triangle KLM via angle similarity. Okay, so because of those triangles are similar to each other, then we know that there are proportions between respective sides. Okay, so let's go ahead and establish proportions to find LM and MN. Okay, so the first thing we're going to do is establish the following. We're going to say that LK divided by LJ is equal to LM over LN. Okay, so this proportion that we've established is essentially this length divided by LJ, okay, or the proportion of LK to LJ is the same proportion as LM to LN. Okay, so now that we have those proportions, then we can go ahead and substitute those values or those segments with known values. Okay, so for LK, we know that LK is 3, and so we can go ahead and add that. We could say that 3 over LJ, okay, now watch this. LJ is this entire thing, okay, so that's going to be 3 plus 5. Okay, so 3 plus 5 is LJ, and that's going to equal LM, which is what we're looking for, over LN. Okay, LN is what? We're told that LN is 9.6. 9.6. Okay, now that we have that, we can do our cross multiplication and say that 3 plus 5 times LM is equal to 3 times 9.6. Okay, and let's go ahead and come over here. We know then, therefore, LM is equal to 3 times 9.6 divided by 8. Okay, and solving for LM works out to be 3.6. Okay, so now that we know that LM is 3.6, we can now determine MN. And how do we do that? Well, MN is equal to the entire length, which is LN, minus LM. Okay, so let's pause there for a minute. This length is equal to this entire length minus LM. Okay, so we take this entire length and we take out LM, what we have left is MN. So now that we've established that relationship, we can go ahead and plug in our known values. And so MN is equal to LN, which is 9.6, that's given to us in the problem, minus LM, which is 3.6. We just calculated that. So that means MN is equal to 6. Okay, MN is equal to 6, and LM is equal to 3.6. Okay, so we've essentially answered the first two questions, LM and MN. So the last step is to answer the question, are the sides divided proportionally? Well, let's go ahead and test this out. In order for this to be proportional, right, or the sides divided proportionally, we would say the following. KL over KJ would have to equal LM over MN. Okay, so let's go ahead and figure that out. Is 3 divided by 5 equal to, and I'll put a question mark here, equal to LM, which is 3.6, divided by MN, which is 6. Okay, 3 divided by 5, it works out to be 0.6, and 3.6 divided by 6 works out to be 0.6 as well. Okay, so that checks out. Okay, so I guess I should move this work down to here in step 4. Okay, and I should move this other piece that I did in step 2 down to step 3, just to be accurate and clear here. Okay, so this belongs here. So step 2 was just establishing the proportions, and then step 3 was actually working it out to identify LM and MN. Okay, so my apologies if that confused you, but hopefully that makes it a little clearer. Okay, so then after all of this work in this example, this leads us to the following theorem, and that is called the side splitter theorem. And essentially, what this is telling us is the following, and let me go ahead and adjust this for a second. Okay, if a line is parallel to one side of a triangle, okay, so let's say this line is parallel to this side of the triangle and intersects the other two sides, right? So it intersects this side and this side, then it divides those sides proportionately. So AM over MB is equal to CN over NB. And that's what we saw in the previous example. Okay, so that is the side splitter theorem. Okay, now the next theorem, Theorem 9.6, is the triangle mid-segment theorem. Okay, now this theorem says that if a segment joins the midpoint of two sides of a triangle, meaning the midpoint of this side, which is G, is joined to the midpoint of EF, which is H, then this segment is parallel to the third side, which is here, okay? Parallel to the third side, and I apologize for this again. Let me go ahead and adjust that. Okay, there we go. So it is parallel to the third side, which is this, DF, and GH is half the length of DF, okay? So this triangle midsegment theorem, when we join the midsegments, we end up having parallel lines, and this length, GH, is half of DF, okay? So let's go ahead and apply these two theorems to the next couple examples. All right, so in example 2, we're going to use the side splitter theorem, and the question here is, what is the value of x for triangle PQR? Okay, now because of the side splitter theorem, we can easily establish the following proportions. We could say that x plus 2 over 12, so the ratio of x plus 2 to 12 is the same ratio as x to 9. Okay, so let's go ahead and write that down. The ratio of x plus 2 to 12 is equal to x over 9. Okay, so now that we've established this proportion, we can go ahead and solve for x by cross multiplying. So this would be 9 times x plus 2, and that's going to equal 12x. Okay, and then distributing the 9 across x plus 2, this becomes 9x plus 18 is equal to 12x. Okay, so now we're going to move this 9x over to this side by subtracting 9x from both sides, and when we do, we're left with 18 is equal to 3x. And then dividing both sides by 3, we find that x is equal to 6. So this is our answer for x. Okay, let's move on. Here's a corollary to the side splitter theorem, and this basically says that if 3 parallel lines intersect 2 transversals, okay, so we have line L, line M, and line N, and they're all parallel to each other, and they intersect this transversal and this transversal, then it says that the segments intercepted on the transversal are proportional. Okay, so for example, the proportion of AB to BC is the same as the proportion of DE to EF. Okay, so that is the corollary to the side splitter theorem. So let's go ahead and take a look at an example. So here we have a reflection pool that is separated by walkways parallel to Lincoln Street. Okay, here's Lincoln Street, and pools are separated by these walkways here. They're parallel to Lincoln Street and Jefferson Street. Okay, and the city wants to add additional tiling around the pool. Okay, or all around the pool here. And the question is, how much tiling does x, so this length here, represent? Well, based on the corollary side splitter theorem, we could say that the ratio of x to 60 is the same as the ratio of 24 to 72. Okay, and we can use that corollary because these are our parallel lines, and here are our 2 transversals. Okay, so then we can go ahead and set that up. X, the ratio of x to 60 is equal to the ratio of 24 to 72. Okay, now before I cross multiply, what I'm going to do is reduce this fraction. Okay, and we could see that 24 goes into 72 3 times. Okay, so 24 goes into 24 1 time, 24 goes into 72 3 times. So then this becomes x over 60 equal to 1/3. Okay, now we can cross multiply and deal with numbers that are smaller. So cross multiplying, we get 3x is equal to 60, and dividing both sides by 3, we find that x is equal to 20. Okay, so that is our answer for this example. All right, now let's move on to the last theorem for this lesson, and that is the triangle angle bisector theorem. Okay, so this basically is saying that if a ray, so here we've got Vx as our ray, and it bisects angle UVW, so we see that this angle here, UVx, and XVW are equal. So if it bisects it, those angles end up becoming equal. And the opposite sides, and it divides, this bisector divides the opposite side into two segments, okay, such that the ratio between the segment is the same as the ratio between the sides adjacent to each segment, meaning this bisector, okay, creates two segments, UX and WX, okay, and the ratio of UX to WX is the same ratio as UV to WV, okay, so the ratio of UV to WV is the same as the ratio of UX to WX. All right, so let's go ahead and apply that to an example. Okay, so here we have triangle ABC, and we have a segment that bisects angle ABC exactly in half. Okay, so this angle here is the same as this angle here. And the question here is, what are the values of AD and DC? Okay, well, based on the triangle angle bisector, we would say that the ratio of 10 to 16, right? So let's go ahead and write that down. Ratio of 10 to 16 is going to be the same ratio as X to this segment. Well, what is this segment? This segment is 13 subtract X, right? If you have this entire segment and you take away X, then you're left with this segment. So then the ratio is going to be X over 13 minus X. Okay, so we can go ahead and cross multiply here. 10 times 13 minus X is equal to 16X. Then we're going to distribute 10 across 13 minus X, and we get 130 minus 10X is equal to 16X. Now what we're going to do is move this negative 10 to the other side, and we do that by adding 10X to both sides, and we get 130 is equal to 26X. And then the last step here is to divide both sides by 26, and we get X is equal to 5. Okay, so now that we know X is equal to 5, we would say that AD right here is X, so AD is equal to 5, and CD, or DC in this case, DC is equal to AC minus AD. And AC is 13, and my AD we just solved was 5, so 13 minus 5 works out to 8. Okay, so AD is 5, and DC is equal to 8. Okay, hopefully that made sense and I didn't go too quickly, but if you missed any of this, please go back to the beginning of the recording and listen to this again. Thank you.